Welcome to Understand the Math. In this problem, we're asked to find the dimension of the subspace spanned by these following vectors. Let me tell you what we're going to have to do to solve this problem. The first thing that we're going to do is we're going to create a matrix A with columns that contain these vectors. We're then going to take our matrix and we're going to put it in echelon form, and then we're going to count pivots. The number of pivots is going to be the dimension of our subspace. Whenever I teach linear algebra, I always find that this problem is one of the most missed problems. And I think it's because it's just hard to figure out what you actually have to do. So let's go ahead and let's do this. We're going to take our matrix A, and we're going to let the vectors that we're given form the columns of this matrix. So we have a 1, 0, minus 3, a 2, 1, minus 5, a 5, 4, minus 11, and then our last one is minus 4, minus 3, and 9. And we're going to put this matrix in echelon form. I'm going to go ahead and circle our first pivot. And what we're going to have to do is we're going to have to get a 0 below that pivot. So we're going to use a row operation. We're going to use a row replacement. And I'm going to take row 3 and I'm going to replace it with row 3 plus 3 times row 1. Let's see what this gives us. Our first two rows are going to stay the same. Let's now look at our row 3. We're going to have a 1 times a 3 gives us a 3 minus 3 is a 0. And then we're going to have a 2 times 3, which is 6, minus 5 gives us a 1. And then we have a 3 times 5 is 15, minus 11 gives us a 4. And then lastly, we have a minus 12 plus 9 gives us a minus 3. Notice that our third row is a duplicate of our second row. So that row is going to go to 0. So let's go ahead and let's mark that. We're going to get 1, 2, 5, minus 4, a 0, 1, 4, minus 3, and then a row of zeros. Now let's go ahead and let's circle our pivots. And we can see that our matrix is in echelon form, and we have 2 pivots. So we have 2 pivots. And that tells us that we have 2 linearly independent vectors. So that means that the dimension is equal to 2. The dimension is just the number of linearly independent vectors in a set.
If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.